Okay, this is Mr. Cousage again, and we're back with part 2 of the last section of this chapter. Okay, don't forget the date in the corner. So yesterday we talked about inequalities. We're talking about inequalities, and yesterday, if you remember, let me show you yesterday's notes. If you remember, the inequality was just some polynomial, and then we did things and found out where it's greater than 0. This one is asking for greater than 0, so where was it greater than 0? What if our function was not a polynomial, but it was a rational expression? You do the same thing, but also include the asymptotes. So we know how to get asymptotes. We know how to get zeros, so we got to do both of them. Okay? So here's the first example. 4 over x minus 6 plus 2 over x plus 1 greater than 0. When is this thing greater than 0? When is it above the line, greater than 0? Well, we know that at the zeros, at the intercepts, right, we know it could switch there, but we have to keep in mind that it could also switch at the asymptotes. So we need to find out where the zeros are and the asymptotes. Let's do the zeros first, right? So first thing we do, is figure out the common denominator. Let me cover this up again. So the common denominator is these two things put together, right? So my common denominator is x minus 6, x plus 1, right? I'm multiplying everything by x plus 6, x minus 1, x plus 6, x minus 1, right? So we come back here. What cancels here? The x minus 6 cancels. So we're left with 4 times x plus 1. Here, the x plus 1 cancels. So we're left with 2 times x plus 6. There it is. And 0 times anything is 0. Okay? So got rid of the fraction part. Distribute. Combine. Right? Solve. And you get x is greater than 8 over 6, which is 4 over 3. X is greater than 4 over 3. Now, 4 over 3 is rounded to 1.3. That helps us find it on the number line. So now that we know what the zeros are, there's only one. Now we need to find the asymptotes. So there's the 0. Let's write it down. So at 1.3, it's going to go this way or this way. It's going to switch maybe at 1.3. We haven't checked yet, right? Is it positive, negative? Is it negative, positive? We haven't checked yet. But besides the zeros, we have to check the asymptotes too. How do you find the asymptotes? Well, when is the bottom equal to 0? What x makes the denominator 0? Well, that's easy to see, right? Here, x equals 6 makes this 0, so that's got to be an asymptote. X equals negative 1, right? So that's an asymptote. So these are the asymptotes, 6 and negative 1, right? So I should have done this with you. So these are our key points that we have to check. 1.3, right? That was from the zeros. Then the asymptotes, negative 1 is obviously here. 6 is obviously over here. And then what do? Then we check something in between and see if it comes out to positive or negative. So what did I choose to check for in between? I chose negative 2 for here. I chose 0 for here, because that's easy. 0 is in here. I chose 2 here. That's pretty easy. And I chose 7 over here. Right? So I plug those in to see if it comes out to positive or negative. Greater than 0 or less than 0. And of course, I will keep the ones that are greater than 0, because that's what I'm looking for. So I plug in negative 2, and it comes out to negative. Okay? What's the answer? I don't care. What matters is that it comes out to a negative. So that's negative. I plug in 0, and it comes out to negative. I plug in 2, this area here, and it comes out to positive. I plug in 7, it comes out to positive. So now I know it's greater than 0. This function is greater than 0 from here onwards. It's positive. Greater than 0 and positive mean the same thing, right? From 1.3 onwards. And I remember 1.3 is really 4/3. Now, at 6 is an asymptote. Do you remember what asymptote means? We touch that line, but we never reach it. So there is no answer at 6. So we kind of have to split up the answer. Right? There's nothing there. Right? So we have to say from 1.3 to 6 and from 6 to infinity, but not including 6. And this is the way we say it, right? This is 1.3, 4/3 to 6, right? Not including 4/3 because that's right on the line. Not including 6 because that's an asymptote, right? It's not on the line, but it is an asymptote. So our graph doesn't go there. And then from 6, not including 6 because it's an asymptote, and all the rest to the right. And we put the union because these go together as one answer. All right? So what we learned today is that for rational expressions, you got to do both. You got to do the zeros and the asymptotes, not just the zeros. Okay? So let's try. Let me give you some try problems here. Here's a try problem. Here's 2 try problems. Let's do this one right now. Oh, look, good for you. This is not a rational expression, so you don't have to worry about the asymptotes. You just have to worry about the zeros, right? So let's get the zeros. Let me straighten this out. Let's get the zeros. So first thing you do is I don't know if this is correct. When I did this, I don't know why this switched. So I do -20 minus 20, and I get -14, and I get a 0 here. And now I can solve this. Let me get some white out. I can solve this maybe it started out as a different problem. Yeah, no, it's correct. I can solve this by factoring, right? So I noticed that it factors to this. 7 and -2 make -14 multiplying. 7 and -2 make 5 by adding. So I got my factors. So now I know that -7 makes it a 0 here. +2 makes it a 0 here. So the 2 zeros that I have to worry about, the intercepts that I have to worry about are -7 and 2. No asymptotes to worry about. So I need to check something here, something here, something here. You should always check the 0 because that's the easiest to plug in. Again, I already gave you the answers. But let's say these answers are not there. So let's try -8, 0, 3. Is that what I tried? Yeah. -8, 0, 3. So if you plug in -8 here, you'll come up with a positive answer. If you plug in 0 here, you'll come up with by the way, 0 is easy, right? This is 0, this is 0, so -14, right? You get -14, negative. And if you plug in 3, you get positive. So what do we want? We want these two sections? No. We want to be less than 0. So we want the negative section. Now we have to describe that. From -7 to +2, not including those, right? From -7 to +2, not including. Can you try one all by yourself? Let me show it to you, and we'll end it there. Try this one all by yourself, okay? And I'll see you in class. Remember to ask questions. Okay, see you next time. Bye.